Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this one and practice our z-scores. A random variable x follows a normal distribution with mean 20 and standard deviation 5. Find P of 14 is less than or equal to x is less than or equal to 26, okay? So the probability that that random variable lies between 14 and 26. Okay, so let's see if I can draw a diagram to help explain what's going on. Okay, that's supposed to be symmetrical, as you know. My mean in the middle is 20. Okay, I then split this into 3 standard deviations, so 1, 2, 3, and then 1, 2, 3. Okay, so 20, my standard deviation is 5, so that's 25, 30, 35, and I come down in 5, so 15, 10, and 5. Okay, so it's wondering how many is between 14, which is here, and 26. Okay, so okay, so what's the probability of being in there? Okay, so we know from the empirical rule that if you go up or down one standard deviation, which would be from 15 to 25, that would be 68%. So you have a 68% chance of being between 15 to 25. Okay. They obviously don't want you to use the empirical rule in this one because they've picked values that don't, I suppose, lie nicely within, I suppose, the empirical rule percentages. Okay, it's 14, which is a little bit outside -1 standard deviation, and it's 26, which is up a bit from 1 standard deviation. Okay, but I do know that plus or minus 1 standard deviation is 68%, so therefore I'm expecting my value to be 70 something. Okay, that I do know from the empirical rule. So the easiest ways is to literally normalize this data. Okay, so in other words, what we do is we're going to put our mean here. We're going to normalize it that our mean is 0, and we're going to go up in set standard deviations. Okay, so how do we do that? Well, we do it using the normalizing or the standardizing formula, which is here on page, what is that, 34 of the log tables. Okay, so there's a few stats pages in the log table, stats and probability. You have your mean, your frequency distribution table, and so on and so forth. And we'll come back to these a few times as we do this set of exam questions. Okay, so this is from the log tables. It's our standardizing formula, and it tells you that a z-score is equal to the value that you're testing minus the mean over the standard deviations. So it's what we call a two-tailed test. So we're going to, and two-tailed because I've got it between two values, okay? And I'll explain again as I go. So I'll do this one quite slow because it's the first z-score one I've done with you. So I'm going to do it once for 14 and then for 26. Okay, they're going to be the value that I test each time. I'm going to compare it to the mean, and I'm going to compare it to the standard deviations. Okay, so by subtracting the mean off it, okay, and dividing by the standard deviations, I'm really saying, well, when I do 14, for example, I'm really saying, well, how far away are you from the mean? and that's the subtraction part. And how many standard deviations exactly is that? Okay, so let's see what that looks like when we put them into the formula. Okay, so my first Z value is 14. That's what I'm going to test. So 14 minus the 20 over the 5. Put that into the calculator. So hit the fraction button. 14 minus 20 over 5. And it's minus 1.2. So remember me saying it was a little bit more than one standard deviation down. Well, it's in fact minus 1.2 exactly. Okay. And I'll come back to him now in a minute. What's my other one? So let's test my other Z score. That's 26 minus 20 over 5, which is again 6 over 5, which is plus 1.2. Okay, so now I want to also draw a diagram here again, okay? So let me explain how Z scores tables work, okay? So what I'm going to do now is I'm going to look up this value in the Z score table, and I'll tell you what happens when I do that. So let me draw it first. There's my mean in the middle, not very symmetrical. There's my mean, and there's my 26, okay? And we know that's a Z score value of 1.2, okay? So when we normalize it, like we've done using this formula, we're 1.2 standard deviations above, okay? So if I flick on another couple of pages in my Z scores, in your log tables to page 36, this gives me a table of Z score values, okay? Or I suppose probabilities of being below that value. So let me draw your attention to the diagram up here and the shaded region. Okay, so when you look up a Z score value in this table, you are getting the probability of being below that value. No matter what value you look up, you are finding the probability of being below it. Okay, so what does that mean? Well, when I look up 1.2, like I'm going to do now, I am going to get the probability not of being between these two values, but of being from here, from the very start up to here. Okay, so let's look it up and let's see what we're doing. So to look up 1.2, okay, I go to 1 here. Well, I don't. I come down here to 1.2. And this is my second place of decimal across the top. And you know 1.2 is the same as 1.20. So this is my Z score value for 1.2. Okay, it's 1.20. So it's 0.8849. Okay. Okay. Now, how do we handle the minus numbers? If you again look at these Z scores, you can see that there's no minus values in it. Okay, we go from 0 and we go up to 3. So we go up to 3 standard deviations. So in other words, we do the positive side of that normal distribution curve. We have no values in our log tables for the negative ones. And why is that? Well, it's because of symmetry, okay? They felt there was no need to put it in. So if that's the case, how do I look up? I'm going to pretend that's 1.2 there in the log tables, okay? Let me write it in orange or something so that it's quite different to the colors that's there. So I'm going to pretend that's 1.2 just there on that line because it's close enough to 1.2. So how do I look up minus 1.2 then, which is down here? Okay, because what do I want to do? Well, when I looked up 1.2 and I got 0.88, whatever we got, okay, I got all of that area there. Okay, all the bit that's in grey. But remember, I only want what's between these two lines, what's between 14 and 26, okay? So what we do is we try and find the area here, and subtracted off 0.88, I can't remember what, 8849. So I hope that makes sense. The bit in blue is when I looked up 1.2. I then need to find this little piece here, okay, and subtract it off the blue, and then I'm left with just what's between the orange. So how do I get that piece that I've coloured there in purple? Okay, you use symmetry. Okay, can you see that that purple bit is in fact the same as this? Okay, so therefore, so for minus 1.2 then, I do 1.0, so 1 minus 0.8849. Okay, 1 representing 100%, so that's everybody, okay? But I'm just doing it in decimal because the tables are in decimal. And I'm getting 0.1151. Okay, so in other words, we have worked out that if this is 0.8849, then this piece here is the remainder 0.1151. Through symmetry, that is the exact same as this piece. Okay, so that's why that is the equivalent of minus 1.2. Okay, so therefore the probability of being between minus 1.2 and 1.2, which is the same as being between 14 and 26, it's just normalized, is 0.8849 minus 0.1151. I subtract this little bit in purple off the whole thing. Okay, so 0.8849 minus that, and I'm getting 0.7698, okay, or 76.98% chance of being between 14 and 26. And that feels right because it's a bit above 26. And remember, our highest frequencies are centered here in the middle. So if we go over just even a little bit here in the middle, we get quite a jump in percentages. So much more significant to go over 1 here than it would be to go over 1 down here because the frequencies are much lower here. So that feels right, given it's a little bit greater than 1 standard deviation. So that's what we call a two-tailed test. You have to do it for both values, and you have to be able to flip between positive z-scores and negative z-scores. The easiest way, would you believe, is to draw a diagram, a bit like what I did here with the color coding, and just figure it out from there. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.